Hey viewers, Assalamu alaikum wa rahmatullahi wa barakatuh. So we are going to begin with the Mendelian disorder. What are Mendelian disorder? First, broadly, genetic disorders may be grouped into two categories, mainly Mendelian disorders and chromosomal disorders. So in this, Mendelian disorders are mainly determined by alteration or mutation in the single gene. The genes which is having mutation or alteration in the single gene is known as what the Mendelian disorders. These disorders are transmitted to the offspring on the same line as we have studied in the principle of inheritance. See, so the disease is transmitted or inherited in the offspring in the same line. The pattern of inheritance of such Mendelian disorders can be traced in a family by the pedigree analysis. We can learn the Mendelian disorder or Mendelian disease by studying the pedigree analysis. Okay, so most common and prevalent Mendelian disorders are these are some of the examples of Mendelian disorders which we are going to study later on. First is hemophilia. Next is cystic fibrosis. Next is sickle cell anemia. And next is color blindness, phenylketonuria, thalassemia, etc. These are what the examples which the board have mentioned in our NCERT. See, it is important to mention here that such Mendelian disorders may be dominant or recessive. See, we can't say that this is the dominant or recessive. Both things we are going to learn here. Which disease is dominant and which disease is recessive. On what basis, on what criteria they are becoming dominant and what criteria they are becoming recessive. By pedigree analysis, one can easily understand whether the trait is questioned is dominant or recessive. See, with the help of pedigree analysis, we can justify whether the disease is dominant or recessive. Similarly, the trait may also be linked to the sex chromosome as in case of hemophilia. See, sex chromosome means what the allosomes we can say, and particularly in the disease hemophilia. It is evident that this X-linked recessive trait shows the hemophilia is going to show transmission from carrier female to male progeny. See, here the carrier female is mother, which is the X-linked recessive characteristics for the hemophilia, and she is going to work as a carrier here to male progeny, means it's her upcoming male progeny. A representative pedigree is shown in figure. This one, see, for dominant and recessive trait. See, here they are going to be dominant and here they are going to be a recessive. Discuss with your teacher and design pedigree for characters linked to both autosomes and sex chromosomes. See, here the female is affected, or we can say carrier, and married to a normal male. In that case, the progenies will be 1, 2, 3 and 4 progenies are there. Out of 4 progenies, 2 are affected. The male is going to be affected and female is going to be a carrier. Okay, whereas when she got married, when the male son, which is normal one, and he got married to a normal female, at that time their offsprings will be the normal itself. Okay, but what about the female which is carrier? She is married to a normal person, but she having a single or only girl child, and she is going to be a carrier, not the affected one. So here we are going to prove that this is X-linked recessive trait. Okay. Similar way, when the trait is existed previously but it is not in this generation, we can correlate this. Okay. But here two children are what affected due to their ancestor, due to their great or grandparents. Okay, these genes may be existed in their family history and now it is visible in the generations. Okay, so hope so you have understanding this video. Make sure to like, share and subscribe to my YouTube channel. Don't forget to hit the bell icon. So I'll meet you in the next video or in the next short or in the live streaming. So stay tuned. अल्लाह हाफिज़, दुआ में याद रखना.